parameter लिख रहा हूँ यहाँ पे. Okay, first of all, let us see here. You can see here EES. There are different icons here: file, edit, search options, calculate, tables, plot, windows, help, examples. बहुत कुछ दे रखा है यहाँ पे. तो ये हमारी जो सबसे पहली विंडो खुली है इसको बोलते हैं इक्वेशंस विंडो. ठीक है, ये इक्वेशंस विंडो है. ओके, नाउ आई हैव टू राइट सम इनपुट पैरामीटर्स. देखो हमने COP कैलकुलेट करना है. वी हैव टू कैलकुलेट COP. ओके, सो आई एम राइटिंग हेयर calculate COP of simple saturated cycle with input parameters evaporator temperature equal to -25 Celsius and condenser temperature equal to 40 Celsius. Is it okay? And refrigerant as R134A. You can see I have used the curly brackets here. Okay, so let us click here. So you can see it turns out to be blue in color, which means it's not a part of the equations window. It's just a statement only. Okay, and it won't be considered. So now what I am going to do is, first of all, I am writing the input parameters. So I am writing TE. TE means evaporator temperature is equal to -25. Okay. So the question should come in your mind कि ये -25 जो है, whether it is degree Celsius or Kelvin. तो उसके लिए we have this options window. You can go here and see the unit system. Okay. So in this unit system, this is SI system of units. Specific properties, mass जो है that is in kilograms. Temperature units are Celsius. Pressure unit is kilopascal. If you want, you can change it to bar also. Okay. Energy units are in kilojoules, and trigonometric functions are in degrees. Okay, so I can click OK. You can see it here also at the bottom. It is SI, Celsius, bar, kilojoule, mass, degree. You can see this arrow. Can you see it?
Yes, sir.
Okay. Now I am writing AC is equal to 40. So automatically, because I have chosen the SI system of units and the temperature is in degree Celsius, so I don't need to worry about the units here. Okay. Then now if I have to calculate the COP, I know what is the equation for calculating COP. Okay. So first point is I have to calculate the enthalpy at point number 1. This is what we have to calculate now. So let us go to options window. Then choose this function information. From here, choose the fluid properties. Then I need to see, you can see in this, you need to calculate the enthalpy. So this is enthalpy. And for enthalpy, you need a fluid also for which you want to calculate the enthalpy. So let us try to find that whether we have R134A or not. I'm going down here. Somewhere with R, probably R134A will come. This is the R134A. So I have chosen enthalpy and R134A. Two things. So you can see here on the left hand side, it is the function information given here. I have just clicked it. So you can see, you can read about enthalpy from here. Similarly, if I click here on the fluid information, you can know about the fluid from where they have calculated the properties. Okay, the research paper is mentioned here. formulation of for the thermodynamic properties of 112 tetrafluoroethane, HFC 134A, and what are the temperature ranges and pressure ranges corresponding to which the equation is valid. So now I have to calculate the value of H1. So what I will do, I will change it here to 1. Now tell me what are the properties which are required. One is temperature because it is known to me. What is the other property? Tell me.
प्रेशर सर
प्रेशर तो कहाँ से मिल जाएगा बेटा, अभी अभी बताया था थोड़ी देर
ड्राइनेस
Quality,
प्रेशर
quality.
Dryness section.
Quality.
Dryness section.
Quality. So I can now, you can see Ex shows that H1 is equal to enthalpy R134A, T is equal to T1, X is equal to X1. So let us paste it. Now let us go here, check equations. There are 3 equations and 5 variables. No syntax errors were detected. Compilation time is 0.0 seconds. Okay. So now you tell me what are the things which I am missing actually. There are 3 equations. You can see I have written 3 equations here. Okay. 3 equation लिखी हैं यहाँ पे. अब what is the missing information actually? Missing.
Pressure of evaporator and condenser.
Oh no. See, if I have to calculate this
So,
enthalpy,
quality.
just a minute. I have to calculate this enthalpy, then I should know. देखो इसका format क्या है? T is equal to T1. So this T stands for temperature. First T stands for temperature, and on the right hand side it is T1. So point number 1 पे जो temperature है, which is that temperature actually?
So TE.
TE है. So I should change here to TE in place of T1. Either I can do this, or what I can do in, I can say that T1 is equal to TE. This is what I can do. दोनों तरीकों से हो सकता है, वहीं पे चेंज कर दो, और you in the next line you write one more equation. Similarly, if I have to say what is X1, what is the dryness fraction at 1 or quality at 1?
1
1. Okay. So once again I will click here. Now what do you find here? You find 5 equations, 5 variables, no
equation and
syntax
5
errors are
variables.
detected. Compilation time 0.0. Okay. So here I was clicking check equations. You can see it here. Check equations, a tick mark sign. To the right of it, we have the solve equation, solve icon actually. So I have clicked it here. So I get a solutions window here. You can see it here. What is the value of enthalpy here? I just clicked it here, 235.3. The temperature is minus 25. T1, TC 40, TE minus 25, X1 is equal to 1. So all the values are given to me, and on the top of it, we are given with the unit system, SI system of units, Celsius, bar, kilojoules, mass, degree. So whenever I will be calculating the value of the pressure, I will be getting the answer in bar instead of kilopascal. Okay. So I have got it. Now I have to go to point number 2. For point number 2, we have discussed what we need actually. We need 2 properties. One was pressure of the condenser, because I told you, you can see it here. This is the diagram. Okay. Can you see it here? This is the diagram. And for point number 2, you need to have 2 properties. One is condenser pressure, which is equal to P2, and other is the entropy value, S2. So first of all, how to calculate entropy at point number 2? We have to actually calculate entropy corresponding to point number 1 first of all. So I go to options. Once again, click function information. Now in here I have chosen fluid properties. So already, because I have chosen it earlier, so it's there. Clicked here only. So now I go for searching for entropy. You can see it here. This is the entropy function. On the right hand side, fluid is 134A already chosen. Once again, you can go for the similar properties, that is temperature and quality. And now you can see that the function is changed to entropy. Okay. So I paste it here. So this is now S1, which is equal to entropy R134A, T is equal to T1, X is equal to X1. So first of all, you see here 6 equations, 6 variables. Okay. And then I can solve it. So you can see it here. I get the value of entropy also in along with other properties which we have already calculated. So what should be my next equation? I should write S2 equal to S1. Okay. So I can once again go to tick mark, see 7 equations, 7 variables, no syntax errors. The moment you will have a syntax error, it will not solve actually. For example, if I make some mistake, for example, here there is a comma, I remove this comma. Now let us see. So it immediately says two independent variables must be supplied for this thermodynamic function. Valid property indicators are this. Okay. So because there is some problem. So जब भी if you will do some make some mistake, it will tell you. But you should check for it that what is the mistake actually. So here there is a mistake in syntax. So now once you can check it. 7 equations, 7 variables. Okay. And now I go for checking it. Calculation of the value. So S2 comes out to be equal to S1. This is the equation, last equation which I have written. Okay. Now am I able to locate the point number 2? Is point number 2 be plotted now or not? You can see it here. I have calculated S2 here. What is still remaining? I need one more property to locate this particular point. So I have to calculate the value of PC, which is equal to P2. So let us go back to the options window, go to the function information. Now I need pressure. So this is the saturation pressure. Okay, for R134A, and I have to write independent properties, which is temperature here. So what I can do is instead of 1, I can say write it as C. The moment I write it C, you can see here the format of the equation which is written here. P sat C is equal to P sat underscore sat R134A, T is equal to TC. Just see it. If I change it to 1, so T1 changes to 1. And T sat on the left hand side also changes to 1. Okay. So let us keep it as C because I want to calculate the pressure at point for the condenser pressure. So I paste it. See, basically right hand side, you should not change much. Means this is basically the function. This part is the function. Okay, you should not change it actually. Left hand side, you can always change. What you can do is you can remove this part. P is equal to, it's PC now. Okay. The right hand side, I have not done any change. So now you just check it. 8 equations, 8 variables. Okay. So let us now calculate, solve this. So now you can see 10.17 bar. Okay, so pressure has been calculated. Is it okay? Any questions till now?
No, sir.
Okay, so pressure has been calculated. Now let us move to the next part. Now we have two properties. We have value of P2 also. P2 is equal to PC. And S2 has already been calculated. Now what I need to calculate? Tell me. You
H2,
can
sir.
see here 9 equations, 9 variables. Tell me what I have to calculate.
Sir, H2.
Okay, so options, go to function information. I have to calculate H2 which is enthalpy. So what are the properties which I should look for? Okay, left hand side I have, you can see 5 properties, 6 properties. So which one should I choose?
So pressure and entropy.
Okay, pressure, and right side I can go for entropy. And I can say that this particular point is 2. Okay, so I will paste it here. So do you think that we will be able to get the answer? First of all, let us see it here. 10 equation, 10 variables. And you can see it here. Let us solve it. So it is 282.4. We were able to solve it. Okay, enthalpy आ गया हमारे पास. Now suppose the question would have been, I can say I have on the top I have written some input parameter. Now I want certain output. Okay, I am writing it here. I need COP. I need T2. I need specific refrigerating effect QE. I need say mass flow rate. If I need a mass flow rate, then there is one more input parameter which is required, which is actually the TR, tonnage of the system. So I am writing it here. Tonnage is equal to, let us say, 2 TR. Okay, I have written it here. And what else you would like to have? You would like to have, let us say, QC, heat rejected in the condenser. Okay, and you would also like to calculate the power of the compressor. These are some of the outputs. So now let us calculate the temperature at point number 2. Options. Go for function information. Fluid properties once again. Temperature. I am searching for temperature now. So this is the temperature. So what are the properties which I require? Tell me.
Pressure.
Okay, pressure and
Enthalpy.
Sir, quality.
Entropy, sir.
see, point number 2 is where it is in superheated region. Okay. See, the way you have calculated the enthalpy, the same way you can calculate the temperature also. You don't need to change even the parameters. Like we have taken H2 is equal to enthalpy. Okay. For corresponding to refrigerant 134A, P is equal to P2 and S is equal to S2. So I can just change the function and keep the parameters same. वही ले लिया, pressure or entropy. But now it is temperature. So just paste it. Doesn't matter. The function has changed now. So for same pressure and temperature entropy, now it will calculate the temperature. Okay. So let us check the equations. Okay. Now see, there was an error. What is the error? The error is I have written this in brackets and I haven't put the curly brackets, both the sides. I'm going to change these brackets to the curly brackets. Now let us see it here. 12 equations, 12 variables. Okay. So now calculate the temperature. Are you able to get the temperature T1? T2, 50.04 degrees Celsius. Okay. No need of calculation of CP. The equation which you use, T2 is equal to T2 dash plus CPG log natural T2 dash by T1, means whatever you are using there, you don't need to write it here. Okay. This is the equation what you write. So we are able to calculate it without calculating the value of Cp, without needing the value of Cp. So H2 is calculated. Now let us calculate the value of H3. Go to options, function information. Now I need H3, enthalpy is needed. Enthalpy. So which properties do I need for calculating enthalpy at point number 3?
Sir,
So
quality.
temperature and quality.
Temperature and quality. Okay. So the point number is 3. So I am changing it to 3. Okay. So I will paste it here. Now have we defined T3? No, we haven't defined T3 because T3 is nowhere on the top. You can see it here. 13 equations, 15 variables. There is no syntax error, but you won't be able to calculate it because equations are 13 and variables are 15. You know, 2 equations, 2 variables, it can solve. 3 equations, 3 variables can be solved. Okay. Same way, we need 2 more variables. So either you change T3 to TC, or in the next line, you can write T3 is equal to TC. Okay, then there is no difference in small letters and capital letters. For example, even if I have used here TC, okay, and on the top you can see I have written capital T and small c, but here I am writing both as small TC and TC. They are different actually, but there is no distinction. You can see 14 equation, 15 variables. Then what I will do, now I am going to write the value of x3. I'm using capital letters, whereas here it is written in the small letters. So there won't be any difference. So I'm putting it as 0. Okay. So you can see 15 equations, 15 variables. So it doesn't distinguish it between small and capital letters. It is same for the software. Okay. Now I can go for the calculation. Am I able to calculate H3? Yes, I am able to calculate H3. Is it okay? Is it all right?
Yes, sir.
Yes, sir.
Okay. So now what I will do, what is the value of H4? How to calculate
Equal
H4?
S3 equal.
Okay, H4 is equal to H3. Now, what are the outputs required? I require T2, specific refrigerating effect QE, mass flow rate, QC, power of compressor. Okay. So T2 I have calculated already. This is already calculated T2. Temperature after the compressor, after the compression, or discharge temperature we have calculated. Now we have to calculate the COP or QE, specific refrigerating effect. So I can say QE, or rather it would be easier for you, I can write specific refrigerating effect. But you should remember, whatever you are writing, you should know what is the value of specific refrigerating effect.
H1
Tell me.
minus H,
Hmm?
H1 minus H4.
H1 minus H4. Let us check it. 17 equations, 17 variables. So let us see where is SRE. This is here 127. So specific refrigerating effect is 127. Okay. Then let us calculate WC. So this is also specific. Okay. What is the value? So
H2
I
minus
will
H4.
what I will do, I will change it here. Instead of SRC, I will write QE because it is heat of evaporator or specific refrigerating effect. Okay. WC will be
Sir, H2 minus
H2
H2
H1.
minus H1. Okay. Let us calculate it. WC. So 47.12. So I can always calculate the value of COP now. COP is equal to, tell me,
Sir,
QE,
QE upon WC.
QE upon WC. So let us calculate it. Where is it? COP is here, 2.696. Okay. So we have calculated this value also. Then we have to calculate the mass flow rate. So I will write MR, mass flow rate of the refrigerant. Okay. So if you want that there has to be, there should be dot over its head. So what I will do, I will underscore dot. Okay. That will be equal to, how to calculate it? Do you remember the equation? Month of refrigeration. So multiplied by 3.5167. So what will be the unit of this quantity?
Sir, kilowatt.
Kilowatt.
Kilowatt. Divided by, what should I write?
Refrigeration effect.
Specific refrigeration effect. So I will be getting the value in kgs per second. So 20 equation, 20 variables. So MR, mass flow rate. So 0.05536. It says something else, kg per kilojoule, but it's actually, it is kg per second actually. Okay. So don't worry. If you are clear about the units, you should not worry actually. Okay. Because it's seeing mass on the left hand side. M stands for the mass and QE has the units kilojoule per kg. So it is giving units as kg per kilojoule. Okay. Reciprocal of kilojoule per kg. So don't worry, but that this answer is correct. The units are kgs per second. So I can write it here also, kg per second. Probably it will give in the answer also. No. So we can change it. I will tell you how to change it. Okay. So this is for your reference. Okay. What next we have to calculate? We have to calculate the power of compressor. So I can say WC underscore dot. So it becomes power because we have earlier calculated WC. Here you have not multiplied by the mass flow rate. So WC dot means its power. So it should be equal to MR dot. So I am copying it from here and pasting it here, multiplied by WC. Is it okay? Let's see what is the answer here. You can see 2.609. So this is the answer. Okay. Now why no units are shown here? You know that when it was calculating the unit of QE, it was coming out to be kg per kilojoule, and you are multiplying by WC, which has the units of kilojoules per kg. So for it, for the software, it's a non-dimensionless number. Okay, which is not right actually. It is in kilowatts. Okay, so WC aa gaya. If you want to calculate the heat rejected in the condenser, that will be equal to H2 minus H3. And if you want to calculate the heat removed in the condenser per unit time, that will be equal to mass flow rate into QC. So you can see it here. This is COP. This we were to calculate. Then T2 was required. Then WC was required. WC power required. Then what else we have calculated? QC. This is the heat rejected in the condenser per unit time, and this is the on per unit mass basis, and this is the value of QE, specific refrigerating effect. What else was required? Mass. So all these parameters have been calculated. Is it correct? Have you got the idea? Tell me. Any questions till now? Yes, tell me. Okay, if there is no question, now let me show you something else. See, you can see x is equal to y. The moment I press it, it is the equations window. Then I can press it here, formatted equations. Now you see it here. What do you find? You can see all the equations in a very means proper way they are written. Okay, you can see it in a very beautiful way. All equations are shown with some space in between them. And if you have to find any mistake in your program, you can always go to the formatted equations. Okay, so you can see it here. I am showing you all the equations. Like here, you can see it is QE divided by WC. This is the way you write division. Okay, so mass flow rate, because I have added kg per second, so it's showing here also. Okay, similarly, all the equations are shown in a beautiful way. Means you can find any mistakes in your program if you see this window. Is it clear?
Yes, sir.
What's your name?
Sir, Abhishek Kumar.
Abhishek. So what about
Yes, sir.
others? Ashish, could you understand?
Yes, sir.
Okay. So I am means because there is no such no interaction, so I can't find your names here also. So it's difficult to remember that. Arvind,
Yes, sir. Clear, sir.
clear. Okay. All right. So now one more thing I would like to tell you. This is the program which I have made. Now I will tell you something more that how we can go further. For example, if we have to plot a graph, that how the COP varies with the evaporator temperature. For example, if evaporator temperature increases, what should happen to COP? Roll number 13. है कोई? Roll number 13, are you
Yes,
there?
yes, sir.
What's your name?
Sir, Nitin.
Nitin.
Yes, sir.
Okay. So tell me, if the evaporator temperature increases, whereas the condenser temperature remains constant, what will happen to COP?
Sir, increase.
COP should increase.
Yes, sir.
Okay. So we would like to see whatever Nitin has just told us that it should increase. So what I will do here, I go to this TE value, choose this TE, I right click here and make it as a comment. Okay, now comment means now it is not a part of the program. So let us see it here. 22 equations, 23 variables, no syntax errors were detected. Okay, all right. But now if you will try to calculate the value of COP, it won't give you. It says the problem is under specified and can't be solved. Show debug information. See, you don't need to go for the debug information because you already know that we have commented one of the variables. Okay, so I will say no. If really if you are making some program and you don't know where you have done a mistake, then you should go for the yes option and search for the parameters which it will show. Okay, for example, once again I am going here. If I press yes here, then it gives you some options here. Okay, that what you can do, you have to read all these things, then you have to see all this. There are many things which are written here which at present you do not know. Okay, so don't worry about that. Now I am going to tell you what I have to do is I have to go for tables. Now here I will select new parametric table, and here I will select say 100 runs. I can go up to 9,999 runs, but I am just going for 100 runs. Okay, the first thing is I will choose that parameter which I have commented. for which I want to know effect. So I will be choosing T from here. So मैंने यहाँ पे T को choose कर लिया, and then I can choose COP. Okay, I can choose all other values, whatever the values are remaining. Okay, now I'm choosing all this. Add it just so that I can see all the parameters. So I press OK. So what do you see here? A parametric equation table has been formed here with 100 runs. So you can see it here. So actually, this software will be calculating the value of COP 100 times. Okay. If you will do this calculation, how much time you would require? कितना time लगेगा? Tell me. So let us say that I go up to a temperature of 10 degrees. Okay. So you can see it has divided the values. How I have gone for it? I have pressed here in this black triangle. This equation, this window opens. TE column 1. First row is 1, last row is 100. Then clear values. If I press it here, the values will be cleared. If I say enter values, I can change the values also. I can go from -25 to, let us say, 5 degrees Celsius also. So it will change. You see the column now. It has changed. Okay. Now, there was only one parameter which was missing in the equations window. You can press it here also. So this is the equation window. You know, you have just commented one of the parameters. Okay, now what you can do is you can click here. Solve table. This is the green triangle. You just click it here and all the values are here. Okay, so you can see it here at minus 25, the COP value is 2.696. You can see it is increasing. This is the 100th run. At 5 degrees Celsius, the value is 6.549. Okay, so this 100 values you can see can be solved within less than a second. Okay, so we have calculated the COP for the variation of the temperature in the evaporator. Now what I can do is I can plot this graph. I can choose a plot icon here, go for new plot window and choose XY plot. So what would you like to have the description in the description box? I can say that I can write variation of COP versus evaporator temperature T. So on x-axis, would you like to take COP or T? Tell me roll number 20. Who is roll number 20?
सर मी सर क्या पूछ रहे हैं सर?
What is your name first of all?
सर दानिश.
Danish. Okay, so you know it. So on x-axis it is TE. Is it correct? And on y-axis is it COP? Is it correct? Is it okay?
On x-axis, yes sir.
Okay. So on x-axis we are taking TE. On y-axis we are taking COP. So yes, we
Yes,
have the
sir.
format here. Automatic format has been chosen. Minimum value is -30 and the maximum is 5. Okay, so I can make it 10 because I have taken up to 5 degree with an interval of 5. Okay, linear. This format is linear, not log. Similarly for COP, minimum value is 2 and maximum is 7. Interval is 1. So I can change it if I want. I can go for say 0.5. Okay, and here in the table I can choose parametric table, and table number 1 is table number 1 only. Okay, and I have run first to last run is 100, so I can choose any number of runs. I can start it from run number 20 if I want and end it at 80. So it depends upon my means what I want to choose actually. So I can go for a line graph, dotted, or solid, whatever I want. Then I can choose a symbol if I want. I can go for, say, I can go for a triangle, and color I can choose is, let us say, blue. Okay. So see, it is, I am not able to click OK because on y-axis COP was not chosen. So now I say OK. Now you just see it. This is the graph. The problem is I have earlier chosen it to be 10. So I can go for x-axis. I can click it here. So maximum I can change it to 10. And interval is 5. It's okay. And let us see ticks. Now there are so many ticks because we have calculated 100 values. So I can say ticks per division. Okay, I will say, let us say ticks per division. Let us say I will say 5. Let us see what happens. It's, I think, now gone more. Okay, so I am just clicking here and there. So what should I do? X-axis, it's called, talking about x-axis. I want to reduce the ticks per division. Okay, that is not so important, that we can take care later on. So let me say okay. So can you see the variation here now?
Yes, sir.
Yes, sir.
So in a similar manner, you can calculate so many things. For example, I can go to plot window once again, but before that I will tell you. For example, I want to know what is the variation of, say, mass flow rate with the temperature. Okay, so I can choose once again a plot, go to new plot window, XY plot. On x-axis I choose, once again I write variation. Okay, variation of uh, mass flow rate versus PE. Okay, so on y-axis I can choose m dot r, and here, so I will, this time I will not take any symbol because there are 100 runs. Okay, so color I will take, let us say, red color this time. And once again parametric table, table 1 and 1 200. Okay, does it shows add legend item? Yes, legend item is important here. If you see here, okay, I will tell you how. Now you just see it here. See, this is the legend item. Earlier we have not chosen it. So this is the mass flow rate in kgs per second. You can see it here. It is reducing. Okay.
Okay.
If you want to plot any other graph on the same plot, so what I can do, I can go for overlay plot. Okay, x-axis is t, and I want to see the variation of, let us say, WC or the power. This is the power. So I will choose the right scale, y2 here, and the maximum variation is interval is given here. I can choose any other color. Symbol I will say none. Color I will go for, let us say, green, and I will say okay. So you can see it here. So now this power is reducing. Now because I have not chosen this legend item, so it's not showing that this green color is for the WC. So it's there. So this is how you can play in this software and plot the curves, graphs. Okay, is it clear?
Yes, sir.
So now
Yes, sir.
saving
Yes,
Yes, sir.
EES example. I'm saving it here. So if you have any questions, you can ask me. Any questions? So I am